All right, this is Math 2, Unit 3.4. We're looking at the worksheet Form K, looking at using corresponding parts of congruent triangles, or sometimes known as CPCT, corresponding parts of congruent triangles to determine whether triangles are congruent or not. Okay, first off, it says state why the two triangles are congruent, then list all other corresponding parts of the triangles that are congruent. In this case here, I have an angle, angle, side, angle, angle, side. So the reason I could say that they're congruent is because of the angle, angle, side postulate. And then, to say that they're congruent, I would write that out as a congruent statement. I would say that triangle QRS is congruent to triangle, in that order, QRS. I'm going to go TWX. I could also make some more statements there of what else is congruent as a result of that. I could say that angle Q is congruent here to angle T, right? And I can also say that I can do a line segment. I can do RS here to here is now congruent to WX. Okay, and I can continue. I can do Q and S and T and X and keep on going forever and a day. But I don't have that kind of time. Okay, next up, it says developing proof. State why triangle AXY and CYX are congruent, and then list all the other corresponding parts of the triangles that are congruent. There's different ways of going about this, so here's one way of looking at it. Okay, I can look at it and say that I have a side here and a side there. Those are going to match. When I look on the bottom corners, I have a double arc and a double arc. So I have a side and an angle matching a side and an angle. And I can also see that they share this side. So I can technically put two hash marks there, and because they share a side, I could say that these two triangles are going to be congruent by side, angle, side. Again, that's just one way of looking at it. And then I could go ahead and label out my parts. I could also look at it if I wanted to and say, well, hey, wait a second. They gave me an angle up here to start with. You're right, they did. So I could actually go with angle, side, angle if I want to use just that section or just that section. So either one works. And again, if you're doing a proof later on, which we will towards the bottom here, then you could pick which route you wanted to go with. Okay? All right. So given QS is similar to RT, or sorry, not parallel to RT. That came out kind of funny. This should be, I don't know why that came out as a square on my photocopy. This should say parallel. I'm not sure why that has a box there, but it does. So QS is parallel to RT. That's what these little arrows indicate. When you have them on your little lines, it means these are two parallel lines. So two parallel lines there, and R is congruent to S. We want to prove that QTS is similar to or congruent to TQR. All right. So to start, determine how you can prove the triangle is congruent. The triangles share a side. That's true. And they have a pair of congruent angles. So we know we're going to share a side, and we have some angles, so we're doing pretty well so far. So because QS is parallel, QS to RT, alternate interior angle SQT, and so SQT, this one here, alternate interior, is going to be congruent to RTQ. So angle RTQ. That's terribly hard to read. Angle RTQ. Alright, so we're saying this angle is going to match this angle. As a result, then, I have angle, side, except angle, angle, side, in order to prove these to be true. Angle, angle, side, to prove the triangles are congruent. So in this case, for number 3, it wants me to write out on the left side my statements, and they already gave me all of the reasons here. So if I was going to write this proof out, I'd begin with the given. I would say what they gave me, QS is parallel to RT, and I would say angle R is congruent to angle S. When it comes to the alternate interior angles are congruent, I want to just basically list those. I would say SQT, angle SQT is congruent to angle RTQ. So I'm working a little backwards there, angle RTQ. And then the reflexive property of congruence means I want to show that this line, QT, is congruent to both sides of the triangle, which it is. So QT is congruent to QT, and that's a reflective property of congruence. Now we have the angle side, which, okay, angle side, no problem here. Basically we're saying, oh, this is going to work here for us. So we're going to say that triangle doesn't matter which way you want to go. Triangle STQ is congruent to triangle RQT. And now that since we've decided that it is actually a triangle, and we know it's a triangle, we could say then that angle QTS, this angle, 1, 2, 3, is equal to angle TQR. So angle QTS is congruent to angle TQR. And that's what we're after there. If I look back at my initial one here, I'm looking at 2 worksheets simultaneously. I apologize for that. This should actually be an angle sign. We're not trying to prove that an angle is equal to a whole triangle. That really wouldn't make sense. So we're trying to prove the angles that weren't listed are equal to each other, congruent. Okay? All right, moving down to number 4, 5, 6. Here's what we're doing here. It says, go ahead and copy and mark the figure to show the given information. Explain how you would prove that AB is congruent to DE, given the information that they give you here. So it depends on what they give you for how you can decide what's going to work, what's not going to work there. Okay, let's look at number 5. I'm going to just do one of these for now. All right. So if I use the triangle that they gave me, now I'll use the triangle they gave me here. It says that AE, this guy here, bisects BD. Bisecting means that that's going to equal that, and this will equal that. It says that DB bisects AE. Oh, got that right. All right, got the AE bisects BD and DB bisects. Yeah, okay. So that's all great. We also know, because of our other things, this is a vertical angle, and that's going to match. And so because that matches, I know for number 5, I can use a side angle side postulate, and corresponding parts of congruent triangles are congruent. So because those are going to match, then the rest is going to be congruent as well. Alright, I'll let you play around with numbers 4 and 6 and see what you can figure out there. Again, I don't know why this prints off, maybe it's my printer, not yours. That should be a parallel line sign there. Everything else looks okay. So that's it for number 4, 5, and 6. Turning the page to the back side, looking at numbers, 2 more to go here. We have 7 and 8, 2 proofs. We have GQ is the perpendicular bisector of FH. We want to prove that FG is congruent to HG. We want to try to prove that this here is congruent to this here. That's our goal right now. All right. So GK is the perpendicular bisector of FH. That is true because that is given information. All right. So definition of perpendicular bisector, what we've learned so far is that means that FKG angle FKG and angle HKG angle HKG are right angles, 90 degrees, right angles. I'm going to mark my right angle. Boom. Now I just mark one of them for now because the next thing, it doesn't say they're equal. Huh. Well, what do you know? Okay, then it says GKF, GKF, and GKH. Oh, yeah, that is. That's the definition of perpendicular bisector, which is there and there, and all right angles are congruent. So we're saying those two angles are congruent now for that part. Okay, no problem. Good to go. Now we have an angle. The next step here, reflexive property of congruence. So we want to say that, hey, this line is the same for both triangles. And the way we write that is segment GK is congruent to segment GK. And that's it there. So now we have that. Now I'm looking for another side, another angle, something else. We says triangle FGK equals HGK. Now the reason they're saying that is by side, angle, side. One of the things we didn't mark up, but it's true, the definition of perpendicular bisector also means that this line segment is equal to this line segment. Not sure why it didn't really, well, I guess it kind of did here in the statement. GK is the bisector of FH. Because that's given, it's inferred that or implied that that is equal to. So we could leave it like that. You don't have to say it again. Other times it looks like they've had you write that out, that FK is congruent to KH, just to state it so that you know that's there. But in the meantime, we'll put it back in there. So this time we have side, angle, side as our postulate for what we know to be true. And because we have a side, angle, side, we know those two triangles are congruent, and then we can say that FG, that part of the triangle, is congruent to this other part of the triangle, HG. Why? Because corresponding parts of congruent triangles are congruent. And off we go. Okay, one final one here for 3.4. Number 8. It says the ABCE is a rectangle. There we go. And D is the midpoint of CE. We want to prove that this line AD is congruent to BD. I'm trying to prove that those two are congruent. So I have my given information already here. They begin by saying that angle AED, this one here, is congruent to BCD. So this angle is congruent to this angle. And they says because it's the definition of a rectangle. Why? Well, a rectangle has right angles, so these two angles are going to be right angles. Good with that. AE, this line, is congruent to BC, this line. That will also be true by the definition of the rectangle. Okay, good to go. Now let's see what we don't know. Step number 4. Step number 4. Because they told us this was the midpoint, that tells me that this is going to break this line into two equal sections. So now I could safely say that ED is congruent to DC, or CD technically. This part is congruent to this part. And the reason for that is the definition of midpoint. Midpoint means it's right in the middle of those two things. Okay? So I'm doing well. I have an angle, I have a side, an angle, a side, a side, an angle, a side. Looking pretty good here. So I could say at this point already that triangle AED is congruent to triangle BCD, and that's by side, angle, side postulate. So the triangle is proven to be the same. Because it's a triangle and they are congruent, I can now go ahead and say that line segment AD here, this other part of the triangle, is congruent to the line segment BD over here. And that's because corresponding parts of corresponding triangles are congruent. All right. And that's it for 3.4 for the day.